It's in this question we are asked about a rectangular swimming pool and it's going to be tiled. The pool's 10 metres long, 5 metres wide and 2 metres deep. The first question asks us to draw the pool and label each side. So obviously it says it's a rectangular swimming pool. That's a 3D shape. We need to go to our exam book and we need to draw a rectangular prism. So we do that by starting with the rectangle at the front. Then probably the easiest way to draw it is just like I've done here. We then need to label it. So we've said that it's 10 metres long, 5 metres wide, and it was 2 metres deep. Right there is one mark. That's all you needed to do to draw the pool. We're now going to be asking questions about area and filling it with water as well. So the next question says, what's the area of the surfaces to be tiled? The thing that we need to be really careful of here is that a swimming pool obviously doesn't have a lid on it. If it's a rectangular prism and we're working out the surface area, we obviously work it out for the top and the bottom for both sides and then from the front and the back. But for a swimming pool, we don't actually have that. So we need to imagine this being a swimming pool if we're standing in it, and if we're going to tile it, we're obviously tiling the sides, the ends, and just the bottom and not the actual top. So if we go to our rectangular prism formula and see that the total surface area is this, we need to write that down. So total surface area equals 2 length by width plus length by height plus height by width. The next step in our process is to substitute what we know. So we know that the length is 10 times the width, which was 5. The length was 10 and the height was 2. Finally, the height was 2 and the width was 5. All right, obviously there was a times in between all of these, and this, importantly, was a plus. So from here, we can either put all of this into our calculator, or we could use solve for x equals, and have an x at the bottom, but we don't necessarily need to have solve there. So I might just keep it out. If we go to our calculator, we need to type in and just be on a calculator page. Let's type in 10 times 5 plus 10 times 2 plus 2 times 5, and bracket, hit equals, and that says 160. That's given us the surface area for the whole thing though, and we need to remember that we need to take away this top section. And the dimensions of this top section is 10 by 5. So we need to take away 10 times 5, which is obviously 50. So this is going to be 110 meters squared. The other way we could have done this is to have gone to the rectangular prism page for total surface area and filled in the gaps. So obviously we're trying to work out the area. The length we said was 10, the width was 5, the height was 2. That gives us an answer of 160 for all of it, and then you would have had to manually, as I said, take off that 10 by 5 top part, so that we've only worked it out to be 110 meters squared. So the next question asks us, what's the capacity of the pool when it's full? And we want to answer it in litres. Capacity is obviously dealing with volume. So we need to now think about the volume of a rectangular prism. So if we go to our exam book and we see here that volume is length by width by height. So it's a bit of a simple one. Volume equals length times width times height. If we substitute in what we know that it is 10 times 5 times 2. Let's put that into our calculator really simply. In a calculator page, we'll go 10 times 5 times 2. Obviously, that's going to be 100 meters cubed. The thing here, though, is that we need to answer it in litres. So if we go to our exam book, we need to remember that when we're dealing with units of capacity, 1 metre cubed is 1,000 litres. So we need to go from 1 metre cubed to 100 metres cubed. And if 1 metre is 1,000, that means we are going to times this answer by 1,000. Obviously, all we've done is we've used this part here because we know that 1 metre cubed is 1,000 litres. And if we put that into our calculator, you'll see that 100 times 1,000 is 100,000. So the volume in litres is 100,000, and we define that with an L at the back. Notice that that's worth 3 marks. The last question asks us, if there are tiles that are 12 centimetres long and 8 centimetres wide, how many will need to cover the surfaces of the pool? To do this, we need to split it into a few parts. First of all, we need to work out what the tiles are for their area. So if we go 12 times 8 on our calculator, we know that that is going to be 96 centimetres squared for each of the tiles. The next thing we need to do is go back to our original total surface area, and it was 110 metres squared. 110 metres squared is the total area that needs to be tiled. We can work out what the 110 metres squared is in centimetres, because we need them in the same units. So if we go to our exam book and find the units of area section, we need to go from metres squared to centimetres squared. So we need to follow that middle arrow. So to do that, we get whatever our answer is and times it by 100 squared. So this is going to say 110 times 100 squared. So if we go to our calculator, let's say 110 times 100 squared, hit enter. Our answer is going to be 1,100,000 centimetres squared. So what that is that we've converted the area that needs to be tiled into centimetres. We know that each tile is 96, so from here, all we have to do is go 1,100,000 divided by 96, and let's do that on the calculator. 1,100,000 divided by 96 equals this answer here, and obviously we need that in a decimal. So to do that, we need to go Control Enter, and we can see that our answer is 11,458.3. Finally, it says answer it to the nearest 100. So this is going to be closest to rounding down to 11,400 tiles. I just want to point one thing out. If you tried to hit Control Enter and work this one out, but it didn't quite work, remember you can go to Menu, Number, Convert to Decimal, and any of your answers or the last thing that you've written will convert into that decimal.